Chapter 2.7a is about parent functions and transformations. Today what we're going to do is learn how to graph what we call parent functions. It's a function that has a general shape that we manipulate depending on the values of the function. You have to memorize the following shape, so make sure you do this at some point. The absolute value graph. First off, the three dots is really what you want to focus on, with the first dot being your home. And in most of these, actually all these, your home point is at 0, 0. But think about this. The absolute value of 1 is 1. The absolute value of -1 is also 1, and so that would be your home points. And I'm not going to use a ruler, but anytime you're really doing an official one on a test, you should. But again, absolute value is going to be two straight lines going from your home point, which is 0, 0, out that way. So notice absolute value is shaped like a V. Looking at this one, y equals x squared, your home point again is 0, 0. But again, think about this. 1 squared is 1. -1 squared is 1. Those are your three home points you're going to manipulate as you memorize it. But the parabola, as you know, is shaped like a U because you should have had those in Algebra 1. It should be at 2, 4, -2, 4. But again, you're not going to be, in terms of general sketches, you're not going to be graded for everything being in a perfect spot, especially if you're just manipulating the parent function. We're not getting perfect graphs. We are looking for graphs of just kind of general thing of where would they be. X to the third. In x to the third, again, your home point is 0, 0. 1 to the third is 1 times 1 times 1, which is 1. But here's where it gets interesting. -1 to the third is -1 times -1, which is positive, times another -1, which is -1. X to the third is kind of like x to the second with this side turning down. So it's kind of like an upward facing S. So it does this. And again, the main thing is that you understand the general shape. That's why you have to memorize it. Y equals square root of x. 0, 0 is your home point, but this is where it gets interesting. I know the square root of 1 is 1 because that's the number that you multiply by itself to get 1. There is really no square root of 2 I want to use. There's no square root of 3 I want to use, but I know the square root of 4 is 2. Square root is the opposite of x squared. So what happens is the graph kind of turns sideways, but there can't be any negatives. You can't do a square root of a negative, and so it's just a half of a u that is sideways for square root of x. Again, 0, 0 is your home point, sideways u, half. And the last one you have to deal with is the third root of x, which has the same home points as 2 or 3 of the other ones. 1, 2, yeah, 2 of the other ones. Because the third root of 1 is 1. Actually, no, it's going back. The third root of -1 is -1. The difference is, just like square root went that way, the third root just adds in the other half, but it's like a S going sideways, and that's where your memorization has to come in. So today your main job is to learn how these graphs are shifted up, down, left, right. Each of these graphs has a home point, as I said, 0, 0. And from this point, this is where you learn from the, you shift the f of x function. So outside shifts, think about graphs. 3/4 x plus 2. This told us to go 2 up. This told us to go 7 down. That still happens like that. Any number that's added on to your actual function moves up and down. So the outside number, as you'll call it, moves the graph up and down. You just have to kind of write that down and make sure you know it. But use the line, your experience with a line, as your hint that this number is your y-intercept. Generally, it tells you where to, where to move up, where to move down to start your graph. The same thing applies when you are outside the grouping symbol. So this would be move 3 up. So it would be that same graph generally, just move 3 up. So that would be it. This would be the same graph, but that would move 5 down. So I go 1, 2, 3, 4, 5, boom, and again I would have a U because that's the general shape. That's why you got to memorize the shape. This would be the same graph, move 1 down. So I would go 1 down, and then I would have my sideways U going that way. So this is what we're kind of looking at with that, and you simplify that notation if you see it on the homework with f of x plus k. In other words, the general graph plus some shift, and what is that doing? That is moving the graph up when it's positive, down when it's negative. The inside number is tricky, but once you understand why, it's not so bad. This -2 would typically make you think that it moves, if you're talking inside going left and right, that it would go left. But the thing is, the value of x that makes this 0 is a positive 2. And so whenever you're inside, the number with x actually is the number you're looking at here, not here. That makes it 0. And the number that would make that 0 is a positive 2. So this actually goes to right. And so that absolute value graph would move your home point over here, and then it would make a V. This one here, again, is a third power graph. But I have a positive 5. But don't look at that positive 5. Think opposite, because you want the value that would make it 0. And since that's a negative 5, that would be 5 left. And so this graph would go 1, 2, 3, 4, 5. And the third power graph, which as I said is an S, would be around there. Third root graph with x plus 4, again, it's with x, so it's inside. X plus 4, don't think about that. Think about what would make it 0, which is negative 4. That would be 4 left. And so 1, 2, 3, 4. Oh, I just messed that up. This would be the third power, so it would be this one. Sorry. Third root is the one that goes sideways, so it would be that one. Something like that. So again, in general, what you're setting yourself up for, that was a mess, but it should be this graph here. In general, what you're setting yourself up for is being able to look at a multiple choice graph or look at a general shape and say this has to be the answer, kind of like I did at the end of last lesson's part where we eliminated options and said it can't be this because that doesn't make sense. Once you see what type of graph it is, you know the shape, which means eliminate anything that doesn't have that shape. Then you use the other numbers to kind of say it should be moving 2 left, 3 up, whatever it might be, and going from there. The reason these numbers, the shift occurs is because the values cause the group to equal 0. Because of this, we use the opposite of what our instincts would tell us. So again, the simplified notation would be x minus h in there. So when h is connected to a negative, the graph shifts right, because remember, if it's negative number here, you're talking about a positive number that makes it 0, which is why it goes right. When h is positive, if that's positive, that means the other number is negative, and there we go. So when we go to graph these functions, first thing we want to do is get our home points. First thing we want to do is figure out how the graph moves. This goes to up, because remember, that's an outside number. That's just like a y-intercept. So what you do is you move 2 up from home, which is 0, 0. You do your 3 home points. So this is my first. It goes 1 to the third is 1. Negative 1 to the third is negative 1. This third is kind of like squared, where it goes kind of like an upwards curved shape. And that is all you're going to be expected to do. As long as your graph looks mostly like the graph is supposed to look, that's what you're looking for. Now I understand some of you might have graphing calculators, but the key thing is, and I'm not going to do all these, the key thing is understanding the concept, because at some point you are going to have to know it. But recognizing that your graph here looks about the same, notice it's going up to about 2 and then moving where it's going to move. Absolute value of x minus 3, looking at this number, that is a inside 3, so we think opposite, which means we think positive 3, so that would be 3 right. And so we go 1, 2, 3, and then we go through our shift, or our steps for making the absolute value graph. So absolute value of 1 is 1, absolute value of negative 1 is 1. Again, remember, I'm thinking 1 right, 1 left. And remember, absolute value is shaped like a V. And so I will do this one real fast, and then I'll never come back to it, because I hope you trust me at that point. But math absolute value, I believe, is here. Yeah, there it is. Absolute value of x minus 3 close graph. Hope I'm right. There it is. So pretty much, again, same picture, went over 3, and that's the general idea, is that you can kind of look at a graph and say, I don't know exactly what it looks like, or I don't know, I don't have a perfect representation, but I can tell you what it looks like, which is the key thing. Again, first thing we want to do is figure out the shift. This outside means 3 up because it's positive, but that is a inside one, which means we think plus 1, which means 1 right. Notice how I mark my page up. Now I make my shift from home doing that. So 1 right and 3 up is there. Then you go to the parent function. This is something squared. Well, that's x squared, so you're going to say 1 squared is 1. Negative 1 squared is 1. Remember that the squared is shaped like a parabola, which means your graph should look like a U, somewhere around that range. Again, I'm not going to graph it because I want to get through this thing so you can get some practice and ask your questions. Here, first thing is, outside number is 1 down. Inside number, positive 2, would make me think negative 2, which is 2 left. And so from home, I go 2 left, 1 down. I then do my home point shift that you need to memorize, which is for third root, it is, third root. Third root of 1 is 1. Third root of negative 1 is negative 1, because you can do a third root, not a square root. And because square root goes sideways, this also should be going sideways and looking something like this. Absolute value of x plus 1 plus 2. Again, first look at the outside number. This goes 2 up. Inside number, I think opposite, which means 1 left. So 1 left, 2 up. The shape is like a V, again, as you memorize it, because it's an absolute value parent function. And there you go. And then the last one that we're going to do today, I think, is your square root graph. That is 3 down. This makes me think opposite, so 1 right. And so I go 1 right, 3 down. And then I go through the square root part, which is over 1, up 1, because the square root of 1 is 1. But remember, I don't know the square root of 2 or 3, but I do know the square root of 4 is 2. And so that is the hardest one to memorize, because it does have that weird shift to it. But write it down. Like I said, put it on a flashcard, look at it a few times, write down what the coordinates are, and eventually as you work with it, you will memorize it. It's not that hard to memorize. You just have to actually care enough to kind of think about it a little bit. But once you get the shapes down, and then once you get the up down number here, left right number going opposite here, it's really not that bad to work with parent functions. We will add one more piece to this tomorrow, and then we will move on to your weekend, your quiz, and then your one more section followed by a test next week. So make sure you're asking questions, make sure you're keeping up, and good luck.